If a rectangular desk has an area of 2x squared minus 5x minus 18 square units, what will be the dimensions of the desk? Okay, so the dimensions of the desk are like the length and the width, right, because it's a rectangle. So we're trying to find out what those dimensions would be. We know that area is found by multiplying these two together. So we had to multiply two things together to get 2x squared minus 5x minus 18. So we're going back the other way, and one way we could do that is factoring, and many of you are great at factoring, so I'll let you do that, but some of you weren't, so I want to remind you we did have a calculator tool to help us, and that was to do menu 331, and that's to find roots of a polynomial. It's degree 2 because our exponent was 2. We're looking for real roots, okay? And so we put in our coefficients, and so the first one is what goes in front of x squared, and that was 2. And then our second was negative 5, and our third was negative 18. Okay, and there's our expression before the polynomial, and we hit enter, and it gives us negative 2 and 9/2. So I'm going to write that down on my paper. We got negative 2 and 9/2. Okay, so now that's the solutions for x. That's not what they asked. They want to know the dimensions of the desk. So what they're asking us to do is to get this as an expression. So what we do when these are the possible values of x, we write down for our factors that it would be x minus. Always we write the x minus, okay? And then we put in our numbers. This one was negative 2. Then our second would be x minus, and then 9/2. Okay, now we can't leave the fraction, so what we do is we multiply by 2 to get rid of the fraction. When we do that, it has the effect of looking like this. This 2 goes up front, okay? But that's because I'm actually multiplying this factor by 2 to get rid of the fraction. So we'd have x plus 2, and then 2x minus 9, and those would be my factors, which in this case is the dimensions that they asked for. Factor the polynomial. Okay, so this is going to work much like our previous problem. You'll notice a couple of things are different though. First off is the exponents. We have up to 4. Okay. Now, when we're factoring, and I kind of forgot about it up here because the way that problem was written, our dimensions, since we only have 2 dimensions, there wouldn't be a GCF for that problem because a greatest common factor that came out of everything, because that would create a third factor. So I didn't pay any, I didn't call that to your attention, but if we look back for a second at the numbers we had there.
Jimmy, we need you in the office area. Jimmy, we need you in the office area. Thank you.
So if we look back at this problem, you'll notice that there was no real number that would divide into 2, 5, and 18 as a factor. So it did not have a greatest common numeric factor. Okay? And using our tool, we have to first identify the numeric greatest common factor. Okay? So on this one, I'm going to look, they're all even, so I know at least 2 is going to go into each one of them. All right. There are a lot of different ways to find your factors. You could kind of go off to the side and write down 24. And then say, okay, I know that's 24 times 1, and 12 times 2, and 8 times 3, and 6 times 4. And then I know that 16 is 16 times 1, and 8 times 2. And now I've noticed both of these have an 8 factor. right? That's the largest number, the greatest value that is a factor in both of those. And then I look here, 8 would have a factor of 8 and 1, right? Right, 8 times 1. So I stop factoring when I recognize that all of them would have the 8. So what that means I need to do is divide the 8 into each one of those. And so that would give, I'm going to write down the 8 out front as a factor, and then I'm going to write 3y to the 4th plus 2y to the 3rd minus y squared. Okay. So now I've factored out my GCF. So I'm going to write that 8 down in my final answer. This is what still needs to be factored. That's when I go to my calculator again. I do menu 3, 3, 1. This time my degree is 4. Still want real roots. Okay. And so now I put in my coefficients. So my first coefficient was 3. That was what was in front of y to the 4th. And then my second coefficient was 2, positive 2. So I put in a 2 there. And then my last one was negative 1, because I had that minus y squared. Okay, now I don't have any other values, so I have to place zeros in those two spots because I don't have an x and I don't have a constant. All right, so 3x to the 4th, 2x to the 3rd minus x squared, that's what I had written down. I hit enter, and these are my factors. Okay, so I come back to my paper, and I'm going to write down that I had negative 1, 0, 0, and 1/3. That was what was on my calculator. So my factors will be 8 times y minus negative 1 times y minus 0 times y minus 0 times y minus 1/3. Okay. This will become plus, so I'll have 8 times y plus 1. Y take away 0 would still be y. Y take away 0 would be y. And then this last one, remember I'm going to multiply by 3 so that I don't have the fraction anymore. So it becomes 3y minus 1. Okay, I'm almost done, but these two y's together, right, I would add their exponent. So I would have 8y to the 2nd times y plus 1 times 3y minus 1. And that's that polynomial factored. What is the vertex of the graph of this equation? All right, so I could take my graphing skills and put that on this grid, but I have a perfectly good calculator that will do the graphing for me, so I think I'm going to go there. And I'm going to type my equation, which was negative x squared plus 2x plus 3. Okay, so I'm going to hit enter, and that gives me my graph. And the question was the vertex. Well, I can see that the vertex is sitting here. It's a little bit difficult for me to tell. I can probably estimate what it was going to be, but you know, I always like to be sure. So I'm going to analyze my graph. So menu 6, and because my parabola is opening down, it has a maximum point, and that maximum point is the vertex. So I move my little dashed line to the left of the line, then to the right of it, and it said maximum is going to be at 1, 4. So my vertex is at 1, 4. So we might want to write that down, that we graphed on calculator, and then we did a menu 6. What was that other key again? Menu 6, 3 for maximum. Okay. Could have been a 2 if we had a minimum point. All right. Which of these are characteristics of the parent function of a quadratic equation? Okay, let's see. The parent function of a quadratic equation has a vertex at 0, 0. Okay, so I remember the quadratic parent function is y equals x squared. So let's check it out. I'm going to clear my graph for a minute. Menu 1, 4. Yes, I mean it. Okay, so I'm going to hit the tab key, and I'm going to graph y equals x squared. Take a look. That's what it looks like, and sure enough, the vertex is at 0, 0, so that is true. Right, the parent function of a quadratic equation opens downward. Let's see, that parent function is opening up, so that is not true. So because it says downward, that's false. Okay, the parent function of a quadratic equation has the y-axis as its line of symmetry. So let's take a look. Here's the y-axis. It's definitely going straight down the middle, dividing this into two pieces, so that is true. So we have 1 and 3, and G says 1 and 3. So perfect. What are the zeros of the function? Zeros of a function is where it crosses the x-axis. So I think the best way to answer that one is to go to my graph. And I'm going to menu 1, 4. Yes. And then I'm going to put in my equation, which was 1/2 times x plus 4 and then x minus 6 Alright, and where is it crossing the x-axis? 1, 2, 3 at -4, 0, and 1, 2, 3, 4, 5, 6, and positive 6. Okay, so the zeros would be at -4, 0, -4, 0, and 6, 0. What is the domain and range of the graph below? Okay, domain stands for our x values, range stands for our y values, because remember that Dr. XY needs his ID. Okay. All right, so that we start at the far left here. We kind of just scan along, and we see that the first encounter with our graph we have is here at -5, and then there's no break in the graph. It continues, continues, continues until 6, where we have this hole. So it goes all the way to 6, and those are our x values. And we know that -5 is colored in, it's part of my graph, but 6 is not colored in. Okay, so we just use the less than symbol there and the less than and equal to symbol here. Okay, the range is the y values, so we kind of scan from the bottom up of our graph, and we see that the first time we have any contact with our graph is at -6. So we're talking about our y values, and then we go along, and then this is the last time we have anything to do with our graph is when y is 2. Now both of those points are colored in, so we use less than or equal to symbol. All right, which shows the functions correctly listed in order from widest to narrowest. All right, so this, you could just graph them all, but sometimes that's a little tricky. So what I want to remind you of is the widest to narrowest has to do with the number in front of x squared. Okay, so we look at the numbers in front of x squared, and the widest is going to be the smallest absolute value, meaning we just look at the number, not the symbol, right? So 7 and 1/7 and 3/4 and 5. We're just going to compare those numbers. Okay, well, I know that 1/7 and 3/4 are both smaller than 1. So they're going to be my two smallest numbers. And then, but I don't know which order they go in. So the easiest way for me to figure that out was just to turn them into decimals. So I go back to my calculator and I do 1 divided by 7. I'll go ahead and do Control Enter. And then do 3 divided by 4. Oop, forgot to do Control Enter. Okay, and that's at 0.75. And my other number was 0.14. So 0.14 is smaller than 0.75, which means 1/7 is smaller than 3/4. Okay. So I would want the 1/7 to be first because it's going to be the widest. That didn't happen here, didn't happen here, and didn't happen here. So it seems like I found my answer. Let's see, the next number was 3/4, then 5, then 7. Okay. I know that these are less than a whole number, less than 1, so they're definitely less than 5, and 5 is less than 7. So I agree B is the answer. How does the graph of y equals 2x squared minus 1 compare with the graph of y equals 2x squared plus 5? All right, well, the only difference in the two equations is right here, this minus 1 versus this plus 5. Now, I happen to remember what that difference is, and some of you may as well, so you can go ahead and answer the question. But for those of you who don't, we can go ahead and do a comparison graph. We'll go ahead and get rid of what was in there before. And we shall graph these two equations. So y equals 2x squared minus 1. And 2x squared plus 5. Okay, so first glance we think it got wider, but that's not actually true because the number in front of x squared is what makes it wider or not. Okay, so the truth here is that it simply moved directions. Okay, so I'm going to do this real quick, kind of pull my numbers apart, and so we can see that blue went to red, right? So as we're comparing, it says how do they compare? Our first choice says the graph of y equals 2x squared minus 1. So that's this line, the blue. Okay, so our blue is 4 units above the graph. Well, it's not above, it's actually below. Okay, so since this says the graph is above, that is not true, so that's not my answer. Okay, the graph is below. Yes, it is. Is it 6 units? I don't know, but I know it's below, so I'm not going to mark that one off. The graph is to the right. Nope, it was not to the right, and it was not to the left. So this has to be my right answer. Let's go and check. Is it 6 units difference? Let's see. 1, 2, 3, 4, 5, and 6. So yes, that is true. All right, so G was our correct answer on 24.